5-1, writing expressions and evaluating expressions. Page 270, number 4. A tank containing 35 gallons of water is leaking at a rate of 1/4 gallon per minute. Write an expression to determine the number of gallons left in the tank after m minutes. We're going to use a proportion table to set up the situation wherein we have a rate of how much we are losing every minute. So we're going to make minutes are X, and we're going to make gallons, the number of gallons we're losing, are Y. And we're going to do this for five minutes. We're going to look at what happens. So it tells us that we're losing water at a rate of 1/4 gallon every 1 minute. So here's my 1 minute. Here are my gallons. So that would mean after 2 minutes, I would lose twice as much. So when I multiply 1/4 times 2, I get 2/4. Or you can also see that I am just simply adding 1/4. After 3 minutes, I can multiply 1 times 3 to get 3, and I can multiply 1/4 times 3 to get 3/4. Or again, I can simply just add 1/4 to my previous quantity to get what's in the fourth column. 1 times 4 is 4. 1/4 times 4 is 4/4, which is equal to 1. And again, just adding 1/4 here. And then for 5, I can add another 1/4, and I can get 5/4, or that would be the same as 1 1/4. So now that I've set up my table and I know the number of minutes and how many gallons I'm losing after each minute passes, what I can do is I can write an expression to show what's happening. And I can use my constant of proportionality to help me write that expression. Constant means it keeps happening. And proportion means that things are in proportion. And so what I'm going to do is I'm going to substitute my Y values in and my X values in and see what that constant is. So you'll notice I'm going to choose one column, and I'm going to choose my first one, and that's 1/4 is my Y value, and 1 is my X value. This is a division problem. 1/4 divided by 1 is simply 1/4. If I look at my next column, I have 2 and 2/4 for my values, but I'm going to put my Y value on top, which is going to be 2/4. And I'm going to divide that by 2. Now, if I'm not sure what that is, because this is a complex fraction, I recall my rules for dividing complex fractions. And that is to just rewrite it horizontally, first as a division problem, 2 is the same as 2 over 1. So I'm going to write it this way because this is in fraction form. I like to have this in fraction form. And then I use my rules for dividing fractions. So those rules say, again, leave this alone, leave my 2/4 alone, change my sign to its inverse, which is multiplication, and use the reciprocal, which remember that's just flipping the other fraction. And I can see then that now I can simply either multiply straight across the top and bottom, or I can cross cancel. 2 divided by 2 is 1 in each case. 1 times 1 is 1, and 1 times 4 is 4. So I can see that my constant of proportionality up here is 1/4, right here it's 1/4, and if I do this one more time with my next column, I take 3/4 and divide it by 3. I'm going to apply my rules for dividing fractions. And I can see that I nicely again have numbers that will cancel out, and I get 1/4. You'll also notice that this is the number that I'm constantly adding as I move from each term to the next term. So my constant of proportionality is 1/4. This becomes my coefficient in my expression. 1/4 is that number that comes right before the variable. When I can find my constant of proportionality, when I have a proportional relationship, I have something happening that it's repeating over and over and over, and I have a certain amount that it is either increasing or decreasing by every single time. That constant of proportionality becomes my coefficient in my expression. So let's look back at our question one more time to make sure we're writing this correctly. It says a tank containing 35 gallons of water is leaking at a rate of 1/4 gallon per minute. Write an expression to determine the number of gallons left in the tank after m minutes. So maybe we want to know 12 minutes or 35 minutes or 16 minutes. So what we want to do is we want to tie our constant of proportionality with that m. That's the coefficient is going to go in front of the variable. So I can figure out how many gallons are leaking out of this particular tank by just taking 1/4 times the number of minutes that it's been leaking. My question, however, wants to know how many gallons are left in the tank after a certain amount of time, number of minutes. Well, I have to go back and find out how much was originally there. Originally, there were 35 gallons of water that were in the tank before it started leaking. So just like our problem with the dog and his dog food, in this tank, I have 35 gallons of water. And it is decreasing by a certain amount every minute. So I'm going to take my 35 gallons and I am going to subtract out my term of 1/4 times m, because if I know the number of minutes I want to know, I can simply put that in for my value for M, and I can multiply that by 1/4 and then subtract that from 35. So that is my answer for number 4. Number 5. Write an algebraic expression that Marshall can use to determine the total cost of buying watermelon that weighs W pounds and some tomatoes that weigh T pounds. How much will it cost to buy a watermelon that weighs 18.5 pounds and 5 pounds of tomatoes? So again, just because this is the skill that we're practicing, I want us to look at this problem in terms of proportion tables. So we're going to have cost